When we try to imagine the scale of the universe, it's generally a hopeless exercise. Our minds are simply unable to grasp something so incredibly vast. With trillions of galaxies and several septillion stars in an observable universe spanning more than 46 billion light-years in every direction, it's no wonder our brains struggle to comprehend the true scope of existence. But perhaps if we break it up into smaller chunks, it might help. Now, there are plenty of videos online about the scale of the cosmos, and some do a great job. But I want to try something a bit different. I want to make it personal. Sure, scaling things down and comparing space to Manhattan or the Grand Canyon gives our brains an anchor, but I've never been to those places. There's still a disconnect when we use them as a measuring stick. It was only when I viewed the cosmos through the lens of the world immediately around me that the picture became clear. I'm Zachary Brighton, and you're watching Terminus. In this video, we are going to illustrate the size of the cosmos, but on a scale that truly hits home. And to do that, we have to start at the very beginning, our own home. Because of the massive size of our moon, the Earth-Moon system is sometimes said to behave almost like a double planet. Compared to the other moons in our solar system, ours is a heavyweight. But even so, it might not be quite as large or as close as you think. When you imagine the size of the moon, how big is it? For most of us, we might think of something like this. We know that the moon is much smaller than the Earth, but it does look fairly big and prominent in the night sky, so this seems about right, doesn't it? The truth is, this is much, much too large. The moon is quite a bit smaller than this. Okay then, how about this? Is this more accurate to how big the moon is? The answer, surprisingly, is no. The moon is still smaller. If we want to match the exact scale of the Earth and moon, we need to shrink the moon down to exactly this size. For many, this might come as a bit of a surprise. We often picture the moon as being larger than what it actually is, but the fact is, the moon is only about 27% as big as the Earth. Our eyes often play tricks on us into thinking the moon is bigger than it really is. Against the darkness of the night sky, there really isn't anything to compare it to, so we often struggle not only at gauging how big it is, but how distant the moon is as well. Here we can clearly see the Earth and the moon to scale. What? You don't see the moon? It is there. We just need to zoom in across space in order to see it better. What looks like a small white dot against the background is actually the moon. On average, the moon orbits at a distance of 384,000 kilometers, as its orbit is not circular, but rather an ellipse. So not only is the moon smaller than we feel like it should be, it's also further away. To illustrate this idea, let's scale the Earth down to the size of a basketball. Along those lines, the moon would be roughly the size of a tennis ball. If we were to simulate their distance in space, how far apart would you place them? 10 feet? 15? Again, the real answer is hardly what anyone would guess. In order to place the Earth and moon to scale, the basketball and tennis ball would need to be almost 24 feet apart. If you place them on a professional basketball court, with the Earth at center court, the moon would be between the top of the key and the free throw line. It just goes to show how easy it is to vastly underestimate the incredible distances between objects in space. Consider the Apollo moon missions in the 1970s. Even with an average speed of about 5,000 kilometers per hour, roughly 1.4 kilometers per second, it still took the astronauts 3 entire days to reach the moon because the amount of distance they had to cover was so vast. Think about if you put 386,000 kilometers, or about 240,000 miles on your car in just 3 days. That's the equivalent of decades of driving to accumulate such a distance. And that's merely the start of our journey. This is an ordinary football. What would it look like if we were to replace this for our sun and scale down the solar system appropriately? We could then place it on a football pitch alongside the inner rocky planets. And much like the basketball and tennis ball, we begin to see the real distances we are referring to when we are discussing the solar system. Mercury would be tight in, not even outside of the centre circle, only about 10 meters distant on this scale, while the orbit of Mars would go more than halfway to the penalty area. But again, this is only for the inner rocky planets. For us to see all the major planets, we need to pull back a bit. Prepare to have your mind blown. This distance is an accurate, to scale model of the solar system with the Sun shrunken down to a football. The orbit of Neptune would still be some 780 meters away from the centre. Remember, there's a football that represents our Sun in the centre of the pitch that is barely visible at this distance. But this is literally just the tip of the proverbial iceberg. If we want to see what scientists classify as the entire solar system, we have to step back a bit further. No, this isn't far enough. If we want to get a visual representation of the scale of the solar system, we need to go all the way back to here. We are some 83 kilometers above the pitch, and it is from this height that you can finally see the inner part of the Oort cloud, a sphere of comets and debris that surrounds the solar system in all directions. For where the football rests on the now too distant to see pitch, outward to 50 kilometers in all directions is the very beginning of the Oort cloud. Think about that for a moment. All this and the Sun is a tiny ball resting in the center of a pitch, far in the distance. However, as extreme as it sounds, we aren't done yet. If we want to get to see the entire solar system, we have to move out to a global scale. From space, can you finally see what the scale of the solar system truly looks like? Based on recent estimations, the outer Oort cloud and the absolute reach of our Sun's gravity might be as far as 3 light years away. On our scale, to cross that distance and thus break through the confines of our little corner of the cosmos, you'd have to travel from London to New York City, a journey of over 5,500 kilometers. The entire Atlantic Ocean's width just to traverse the Oort cloud and make it to true interstellar space. And that's only if our Sun were the size of a football. I hope these scale references are helping you to grasp how insanely and impossibly great the distances are between even relatively close objects. But we have still more to see. Next, we're going to look at the huge voids between stars. When we gaze up at the heavens on a clear night and see all of those bright, twinkling points of light, it's easy to forget just how distant they truly are, not only from us, but from each other as well. It appears almost like a dome over our heads, and indeed, for thousands of years, that's precisely how we envisioned it. But the truth is, while it might look like an endless sea of stars, each one is as far apart from us as they are from each other. Let's take a look at our closest stellar neighbour, Proxima Centauri, at just over 4 light years away. While you might already know that, by definition, it takes the light from our Sun more than 4 years to travel that distance, it can be hard to wrap your head around and visualize. In order to do that, let's strip the outer layers of the Sun away so we can see the true diameter. Now let's shrink the Sun down, much, much smaller than a football. All the way down until it's just 1 millimeter wide. From 1.4 billion kilometers wide, down to the width of a grain of sand. At this ridiculously small scale, it's hard to even make out the planets as they orbit the Sun. The Earth, an invisible speck the size of a red blood cell, it orbits at a distance of about 4 inches. This is by far the smallest scale we've used yet. So, how far away do you think Proxima Centauri is? 1 kilometer? Perhaps as much as 5? Surely it can't be much more than that, right? This is Birmingham, England. Let's place our single speck of sand in the city centre. In order to accurately portray the distance to our nearest stellar neighbour, we'd need to travel southeast to the city of Coventry and place our second grain of sand in that city's centre as well. That's an astonishing distance of nearly 29 kilometres. Just let that sink in for a moment. Picture in your mind a place roughly 30 kilometres away from you, and in that spot is a grain of sand smaller than 1 millimetre wide. That's how distant Proxima Centauri is, over 40 trillion kilometres. That's trillion with a T. And while all the stars in the night sky look like they're clustered together, they are often many tens or hundreds of light years apart. It serves to amplify just how isolated we truly are. And lastly, let's bring everything full circle. We started this exercise by imagining the Sun as a speck of sand 1 millimetre wide. By those dimensions, the entire Milky Way galaxy would still be roughly 1.35 million kilometres across. Why is that number important? Well, as luck would have it, that number is almost exactly the true size of our Sun, a small bit of serendipity. Still, it does illustrate just how absolutely huge space is. Sure, we can think of it as an endless expanse, and that would be more or less correct. But to be able to visualize the distances between the objects we're so familiar with really does put everything into perspective. It makes things tangible in a sense that wasn't there before. Think of how tiny and insubstantial one small grain of sand is, yet it represents more than 99% of the total mass of our entire solar system. Now compare that lone grain against the true size of the Sun, and you have an accurate depiction of our place in the galaxy. It fills me with a profound sense of awe and wonder at all of the marvels the universe contains. I'll leave you with this one final thought. At more than 92 billion light-years across, the observable universe is so enormously huge that you could fit more Earths in it than you can pack hydrogen atoms inside the Earth, about 270 times more. Think about that for a second, the next time you're staring up at the stars.